be looking at another question on Cauchy Riemann's equation. The question says that determine where the function f of z equals to z squared minus z bar is analytic. Meaning, what do you say? Yeah, z squared plus z bar is analytic. So what this question is saying, or what it means, is that determine this. This is the given function. We are giving f of z as this. Question says that determine where the function is analytic. What's the idea of analytic, or you say holomorphic? The idea is that your function, meaning f of z, meaning your complex function, is differentiable at every point, meaning it has differentiability at all value of x, right? Meaning it exists in all the domain. This question is now saying that determine where this analytic occur. Determine where the function this is analytic. Let's say you have a graph of y against x. You have several points. Say you have several points. So the question is saying that at this point, is it analytic? At this point, is it analytic? Are you getting me? Let's say you have about 10 points. So you want to know the point where this function is analytic. So that's what this question is saying. So in this case, what you just need to do is actually the same thing what we've been doing so far, right? Determine a function if it is analytic or not. So you know that if you want to determine an analytic function, or if you want to conclude that this complex function is analytic, Cauchy Riemann's equation must be what? Met, right? Meaning we are saying the partial derivative of u with respect to x is equals to what? The partial derivative of v with respect to y. Then we are also saying that the partial derivative of u with respect to y is equals to negative partial derivative of v with respect to what? X, right? You are going to have this partial derivative if f of z is expressed in terms of u and v, where u is a function of x and y and v is a function of what? X and y. Look at the question given. We are given f of z is equals to z squared plus z bar, right? Now question mark, this function, how can I write it in terms of u and v, where u is a function of x and y and v is a function of x and y? So what we are going to do is that substitute z equals to s plus jy. Substitute z equals to x plus jy into this function. When we say conjugate, we've seen the idea of conjugate. Conjugate, let's say you are given a complex function or you are given a complex number. The conjugate becomes the opposite sign of the function given. So you are given this function, the conjugate is what? X minus jy. So when you see z bar, meaning conjugate, so you are saying that substitute z as x plus jy and substitute z bar, meaning the conjugate of z, as x minus jy. Call this equation 2. That becomes, meaning f of z becomes what? X plus jy all square, right? Plus x minus jy. What do you have? X all into bracket s plus jy all into bracket s plus jy plus all into bracket x minus jy. Let's expand this bracket. What do I have? I have x squared plus jxy plus plus jxy plus j square y square plus x minus jy, right? Where j square is equals to -1 from complex number, meaning anywhere I see j square, I'll substitute -1. So I have f of z is equals to s square plus jxy. Okay, this will be what? j2xy -1 multiplying by y square plus x minus jy, right? So up to this level, what do I have? I have s square minus y square. Let's collect like them now. Let's group. Meaning I'm having s square minus y square plus x, right? plus j all into brackets. What do you have? 2xy minus what? Minus y. Close your brackets. Meaning this is what? F of z. Meaning this is what? F of z. So giving this function as f of z, giving this function as f of z, this is still a function where u is what? Where u, which is a function of x and y, is equals to x squared minus y squared plus x, and v is equals to 2xy minus what? Y. Right? Now let's obtain the derivatives, then substitute. Once we substitute, and these two equations, the left hand side and the left hand side and the right hand side of this equation are equal, it means that the function is analytic everywhere, right? But if these two equations, if the left hand side is not equal to the right hand side, it means the function is not analytic. So let's find the partial derivative. Partial derivative of u with respect to what? X. What do we have? 2x plus 1. Partial derivative of u with respect to y. What do we have? Minus 2y. Right? Then, next up, for your v function, partial derivative of v with respect to x. What's the answer? 2y. Partial derivative of v with respect to y. What do you have? 2x minus 1. 2x minus 1. Alright, therefore, let's verify Cauchy Riemann's equation. Substituting values, what's du dx? Du dx is 2x plus 1. So I'm having 2x plus 1 is equals to what? What's dv dy? The partial dv dy? 2x minus 1. The next one, this is for equation 1. The next one is what? The partial derivative of u with respect to y. That's what here? Negative 2y equals to the negative partial derivative of v with respect to x. What do I have? 2y. Equation 2. Now with this, what's your conclusion? With what we've solved on this board, what is your conclusion for this particular function? Question says that determine where the function f of z is analytic. Determine where it is analytic. Now with what I have here, is it analytic? Is it analytic at every point, or it is analytic at some point, or not for every point, or for every point? Okay, now we said, what's the idea of analytic? When we started Cauchy Riemann's equation, your complex function becomes an analytic function when Cauchy Riemann's equation is satisfied. Do we say that one of it should be satisfied, or both should be satisfied? Both should be satisfied. So let me ask that same question again. Is your function analytic at some point, or for every point, or not for every point? Not for every point. Because when we started, we've seen that a complex function is analytic, or you say it is holomorphic, when the two conditions of when Cauchy Riemann's equation is satisfied, meaning these two conditions must be satisfied before you say that your function is analytic. So with what I'm having on this board, it means my function is nowhere analytic. It is what? Nowhere analytic, meaning that it is not differentiable at every point. It does not have a complex differentiability at every point. So that's what Cauchy Riemann's equation means. So far we've been able to we've understood the word Cauchy Riemann's equation. We've seen that Cauchy Riemann equation is a test. When we say that Cauchy Riemann equation is a test, what are we testing? We are testing the what? Differentiability of a complex function, not just any function, but what? A complex function. We've seen that. We've discussed all what we need to know when it comes to Cauchy Riemann's equation. Then we've solved different types of problems, meaning we can given this question, how do I solve it? So we've done that also. Then lastly, we've also seen the concept behind the harmonic conjugate of a real value function. The harmonic conjugate of a real value function. So these are all what we'll be using, or this is all what we need to know when it comes to what Cauchy Riemann's equation.